Master Hamster, Super Science, Forces and Motion. There are some laws and some pigeons that even a reformed supervillain can't ignore. Join Master Hamster as he learns about the laws of motion, then overcome inertia to build your own experiment.
Peace and quiet. With everyone out of the house, including that goody-goody furball, I finally have the place to myself. Just me, my yum-yums, and the greatest science show ever.
Welcome to Schruten's World. Today we're investigating Sir Isaac Newton's 3 laws of motion. I'm your host, Sir Isaac Schruten. No relation. We'll start with the first law. An object at rest will stay at rest.
You don't have to tell this super genius twice. I excel at resting.
That is, until a force acts upon it.
Shoo!
Crew,
Shoo!
crew,
Shoo! Scram, you feathered pea brain!
Perhaps an example would better illustrate this first law of motion.
Newton's first law of motion in practice. The skateboard will stay where it is until a hamster supervillain steps on it. 1. Force. A push or pull resulting from one object's interaction with another. 2. Deceleration. A decrease in speed and direction. 3. Acceleration. An increase in speed and direction. 4. Friction. A force that resists the motion of one object over another.
According to Newton's first law, once an object is in motion, it will continue to travel in a straight line until another force causes it to slow down, speed up, change direction, or stop. This is called inertia. Here on Earth, there are many forces that act upon an object in motion. Gravity, for example, pulls things toward the center of the planet.
Shoo! Phew! I see I need to be a little more forceful.
The second law of motion is about how much force is needed to move something. Whether pushing or pulling, the strength of the force needed to move an object is determined by the object's mass.
Mass is a measurement that tells you how much matter an object is made of.
The more mass an object has, the greater the force needed to move it.
No more Mr. Nice Hamster.
Perhaps another example would better illustrate this law.
Newton's second law of motion in practice. A mechanopult will throw a marshmallow and a sofa at different speeds, unless you remember to change the settings.
A marshmallow doesn't need as much force to accelerate because it doesn't have as much mass. A bust of Einstein will need more force to accelerate because it has more mass. And a sofa is going to need a lot more force to accelerate because it has a lot more mass.
You! Two can play at this game.
And finally, we come to Newton's third law of motion. For every action, there is an equal and opposite reaction.
Newton's third law of motion in practice. Exhaust shooting backward from the jetpack moves the hamster forward. Exhaust, what's forced out of the rear of the engine. Thrust, a force that pushes the object forward. Drag, friction created by the air that pulls back and slows the object. Gravity, what pulls objects toward the center of Earth. That's down to you. Acceleration, an increase in speed and direction. No thrust here. Gravity taking over. Air resistance works in the opposite direction of gravity to slow acceleration.
Please, shoo.
Well, that's all for today, scientists. And remember, as with all our experiments, don't try this at home.
Get out of here, foul face. It's sciencing time.
Sciencing with Master Hamster. What we want to know: how far you can launch objects with different masses. How we're gonna science it: by building and experimenting with a catapult.
Welcome to Schruten's World. Today, we are studying catapults.
I call it the Spoon-Powered Pigeon Plunker 3000. To plunk things at your own pigeons,
He means build a catapult.
you'll need a foam bowl, a plastic spoon, some tape, and plunkables.
Plunk a what?
You know, cotton balls, pom-poms, marshmallows. Just make sure some of them are a little heavier and some are a little lighter. Flip your bowl upside down and poke about 2 inches of the spoon's handle through the bottom.
Let's tape that spoon in place. We want to launch the plunkables, not the spoon.
Now bring out the target so we can get plunking.
Pigeons don't usually look that vengeful.
You haven't met many pigeons, have you?
Coo? Hold the bowl down, carefully pull the spoon back, and witness Newton's second law in action.
Cotton balls don't have much mass, so you're gonna need a lot of force. Now try it with a marshmallow, Schruten. They have a little more mass and a lot more flavor.
Same force, but more mass, so not as much distance. Be sure to try this at home, kids. See if you can make your catapult throw farther or higher, or even hit a target.
No pigeons were harmed in the making of this comic.
Fury Roach's first law of science says that you have to turn the page and read my facts. Just kidding, it's more of a suggestion than a law. But you should.
Fury Roach's Furious Forces Facts.
You know, if it weren't for the force of gravity, that crate never would have fallen on me, and I wouldn't be the furious roach you see today. Thanks, laws of physics. But forces do a lot more than provide great origin stories for villains. Gravity bringing you down? It sure is. It's constantly pulling you toward the center of the earth, compressing your spine all day long. That means you're about half an inch shorter when you go to bed than you were when you woke up. The man, the myth, the apple tree. Did you hear that Sir Isaac Newton discovered gravity when a falling apple bonked him on the head? He was inspired by a falling apple, but the part where it hit him on the head is probably a legend. The tree that inspired his discovery is real, though. It's almost 400 years old and still grows near his family home in Lincolnshire, England. Rock on, catapults! These machines were invented to hurl giant rocks at castle walls during battle. Now they're mostly used for entertainment, but they can still pack a punch. A catapult named Chunk Norris holds the world record for pumpkin chunking. It threw a pumpkin 4,091 feet which is longer than 11 football fields.
Become a race engineer. Do you have a need for speed? Are you competitive? You might want to be a race engineer, someone who helps design and build race cars. You'll need a love of math and science and a knowledge of forces in motion to be part of a racing team, whether at the factory or on the racetrack. Newton's first law of vroom. Race engineers need to account for forces like velocity, acceleration, and friction to design the fastest cars possible. Safety first. It is extremely important to make a race car reliable so that it won't break down during a race. And, of course, the driver needs to be well protected in case of an accident. Start your engines. Engineers help drivers race their cars as efficiently as possible. Using computers, engineers gather data or information to determine when the driver should use more force, stomp on the gas pedal, or friction, pump the brakes to win a race. Teamwork makes the dream work. During a race, engineers need good communication skills to work with the crew in deciding when to bring the car in for a pit stop, a chance to check the car, update its tires, and make sure everyone is staying safe. The engineer and the pit crew never stop trying to improve a race car's performance, because a race isn't over until every car crosses the finish line.